As already mentioned in the previous section, here we see the 3D representation of the far field. On the right hand side of the picture we have the scale at which we can see how strong the field is. The white rings indicate this as well. We can display different cross sections of the field, 2D cross sections. Very often a cross section gives a more clear impression on how the field behaves in the far regions. And of course we can use all three all the 3D or the 2D cross sections on all three axes. Here we see a very interesting 2D cross section. On the right hand side the F antenna, on the left hand side the excitation source, and we do have quite a field also at the excitation source, and the inverted F antenna is radiating the field, but it's even a bit weaker than the excitation source. So clearly we need to improve the simulation here in order to make sure that the excitation source is not already radiating all the energy outside. Here we have the same picture again in the other cross section, but giving the same impression. So the inverted F antenna is working nicely, but the excitation source is not as good. We can now switch from linear to logarithmic representation. Mostly the logarithmic representation gives a better picture. And we can also choose the frequency. Here we only have one frequency, but we could also use different frequencies in one simulation run. Probably if we have two carrier frequencies, or if we just want to know how sensitive our design is for tolerances. And again, the 3D representation of the complete field. Very nicely we can see that in the axis we have very low radiated field directly in this case x-axis, but otherwise a very symmetric field.